Hello everyone, my name is Roy Jafari and I would like to welcome you to another video. In this video we're going to continue learning about how we go about optimizing our Python code for the purpose of data preprocessing, data manipulation, and data analytics. In this video we're going to focus on a function from Pandas that is very helpful to know when you go about integrating your data from different resources. If you have worked ever with the SQL joining functionality, the function Pandas Merge is pretty much on the same foundational ideas of how a tool go about merging two tables. But if not, don't worry about it. We're going to take a look at this fundamentally. At the same time, what we are going to do, since this is a code optimization series, we're going to compare how using merge would benefit you as far as computational cost versus using other types of perhaps more intuitive way of going about the same integration. We're going to do this using two examples. Let's get started. Okay, so what we're going to talk about today is the function merge from Pandas, right? So it has two manifestations. Basically, there are two ways you can access this function. One is through the Pandas module, original folder. You can call pd.merge when you import pandas as pd, or you can also access the same function from one of the data frames, from the data frame objects of a pandas data frame, right? So then when you do that, you have already specified one of your data frames you want to merge, and the second one should be specified, right? So here when you do pd.merge, you have to specify both of your data frames, what they are, and then use that for joining. But we're going to see that in an example. So the first thing we're going to do is, first of all, we're going to import three modules: pandas, numpy, and datetime. We're going to use this throughout this video. First thing we're going to do, we're going to create two data sets. We're going to do it randomly, random data sets that we're going to basically use that. Basically what we are going to do is we're going to create our playground to learn this new function. All right, so first off, we create this cusdf, which is supposed to be an empty customer df. It has 10,000 rows. We are attempting to input our customer ID, a purchase amount, and a date, right? So let's go ahead and add customer IDs. What's happening here? This is a list comprehension. Basically, it goes through a loop and create cust1 or cust0 all the way to cust 90,999, right? So let's do that. So once we do that, we have our customer name. So these are basically a placeholder for customer names, customer IDs, and then we also use random functions from numpy to create a random number between 1 and 1,000, and also to make it look like more actual purchase amount, we also add two random digits at the end of each of these 109 integers. So once we do that, now we get our random purchase amount as well. And now we also want to create some random dates, right? So this customer bought this in this date, right? To do that, we're using the two functions from datetime. The first one is the function datetime.now, which basically gives us the date of today. Today is where I am right now is July 31st, 2022, right? So I am basically adding 20 days, from 7 days in the future. I'm adding subtracting 21 days from that. So basically I'm getting 1 week ahead and also 14 weeks prior to this date. So that's basically what this function does. This is another list comprehension, and I am using, like I said, datetime now and also datetime time delta. Time delta is basically when you want to add or when you want to subtract date from one another. So if I want to add a day, so I have more date, that's how I go about this. But also pay attention when I create that, I add a day to the, few days, or, it stops like a few days from where I am right now, right, with the day I am right now. But then at the end, I get the date of it. So this is a function from a datetime object. So long story short, once we're done with this function, we are gonna get from 7 days, prior to where I am, the day from I'm right now, and then 21 days overall. So from 24th of July to 4th of July. So these are the dates I have, right? So now here, what I do using another list comprehension, I use one of these 25 dates. I use one of them randomly, right? Randomly, I use one of them to add it to my data, right? So once I'm done with this step, there is a date attached to each of these rows, right? So that's the first data set that we create. The second data set is going to be a temp DF, right? Temp series. Again, I create another list of dates. This time, pay attention. I am creating a list of dates 21 days, including today, and 21 days, before today. And there is a reason that there is a bit of a mismatch between these two windows of time. We'll get to talk about that. But anyway, we use this comprehension to create a temp series, right? Basically, it's, we create a random data telling us today the temperature is 78, the day before was 104, and obviously these are only random numbers, right? So we're just basically creating a playground, right? So now that our playground is created, we've got two sources of data. One is temperature series, basically, it's a data source of the temperature data, and we've got custDF, which is the source of our customer data, right? Now we want to see if of course, the data is random, but imagining if this was a real data, if the temperature of the day impacts the purchase amount of customers, right? For instance, this is like I said, it's a random data, but it's a legitimately interesting question to answer for some type of businesses, right? It would be good for them to be able to predict the future. Anyway, what we need is to use this date in both of these data sources to be able to integrate these two sources, so we can have all the data in one data source, so we can go about doing the analytics that we need to do. So that's the task. We want to integrate these two data sources. So we're going to cover 3 methods here. 2 of them is not optimized, but we're going to cover the third method that is optimized. The first one that you might think about is basically using a loop to go through each of the rows of our custDF and then look up the date and check it from our tempDF, and based on that date, bring the temperature, right? So that's perhaps the worst way to go about this. That may sound intuitive for some of you, but just because you haven't had enough programming data analytics, you haven't had enough programming experience for the purpose of data analytics. But anyway, let's integrate DF, integrate one DF, right? So this is the naming, and then we create a loop, and on each loop we do a lookup based on the date, row.date, and if that value exists, we use that temperature, right? So if that value exists in the index of the series, we use the temperature value. If it doesn't exist, we pass just a none or a null value. Right, so once we run this, it takes 1.5 seconds. The data is not that large. A 1.5 second may sound like an okay time for you, but we're talking about being able to run codes that can run at scale. And $10,000 data, 10,000 rows of data is not really big data. So that's kind of work for us, and we can see that there are some non-value, and the reason is because the dates that we created in our playground, there was some mismatch between them. Basically, we don't have the temperature data for these dates. We created that intentionally to be able to learn more about this function. But anyway, we get to why we did that. I mean, like, we'll look at the examples that this will show itself. We can see that, you know, we do have some null values here, right? So we've got around 3,300 null values, right? So that was the first method. The second method is using the applied function. This is still better method than the previous one. We can see the improvement that we make from 1.5 seconds, but it's not an optimized way to go about this. For this one, first, again, we create another integrated DF to be able to compare these, but we basically first create a lookup function, basically get temperature based on a date. And this function basically looks at the temp series index, and if the date is in there, then it returns the temperature. So now we can apply this function to the costDF date column. And by doing that, we create a new column that is basically the temperature for each date for that customer amount of purchase, right? So we can now run this, and to do that, we have to run this first. And we can see we improved significantly, 108 milliseconds versus 1.5 seconds. Right? You can see like the improvement is a lot by just applying versus doing the loop ourselves, right? And we can see that this is kind of the same output. There are some null values, same reason for that output. The third method, which is the one that we want to learn based on this example, is using Pandas Merge function, and that's going to be very useful if you know how to work with this function. So for us to be able to do that, we need to have the same column in both data sources, right? So for us to be able to do that, we reset the index, and then instead of having date as an index, we have a date as a new column. So that's one of the things that you need for this function. You have to have the column you want to merge your data sets on in the same name within the both data frames, right? So that's very important. So that's why we need to do this pre-processing step. But once that is done, now we can go ahead and do this, and you can see it takes only 11 milliseconds. You can see we improved from even the second best method 10 times as far as how fast this happened. And the reason is there is no lookup that happens here. Basically, Pandas does this in CPU, connect these two data frames together based on this column, and that's why we get much faster improvement. You might say that, Roy, you added this step, previously. This may add some time, so let's just go ahead and add this here so we can also time this as well. So let's go ahead and do that, and we can see that it doesn't really change the time, right? So it's still in the range of 10 to 12 milliseconds, right? All right, so we were able to do this, but now we want to pay attention to the fact that this happened. However, our data used to be 10,000 rows, but here it's like around 6,700. Some data are missing. And when we look at our column temperature, we can see that there is no null value. And what's happening here is the fact that we are basically finding the commonality between the dates and merge them. So if there is a date that there is a date in this column, in the costDF data frame that we don't have at the temperature, it's just going to be omitted. And we will fix that, but this is how this function behave on default settings. So we can change that and we can fix that, but let's see how that works. So a few things that we want to pay attention here is the fact that here we access this merge function from the costDF, one of the data frames objects. But we didn't have to do that. We could have accessed the function from the pandas root itself. So we say pd merge. This time we have to be specific about the left data frame and the right data frame, and then it does the same thing basically. But here, when we access the merge function from the data frame, from the data frame object, we already saying that the right data frame is this data object, right? This data frame, right? So that's the difference between them. But as far as the performance, this does the same performance basically. All right. Okay, so there are a few things to pay attention here. The first one is that we didn't need to explicitly say the data, the column that we want to merge on. If there is a column that has the same name within the both data frames, the Pandas automatically detects that. So since we do have that column, we can go ahead and do this, and it gives us the same results, right? It basically automatically detects that we've got this column on both sides, so it basically uses that. This is not, I would not recommend for you to do this actually. This is better to be explicit about what you're merging on. This is better. You might run into an error, but you can fix the error, and that's going to be a more sustainable code for you to have for other people to read and for other people to understand. There's another note, is that there are 5 different kinds of merge. If you're familiar with the SQL joining, this is basically the same thing. If you've got inner join, this is basically the same concept, right? So the default one is inner, and we've got other types, which is outer, left and right, and also cross. So we're going to see all of this, what that means. All right, so in this image that I just looked up on Google, basically I said, I typed Pandas Merge, and this is one of the pictures that came up. We can see that we've got these 4 types of joins. This is basically merge, the same thing, right? So when we've got inner join, we basically get the commonality between both of the data frames, right? When we have outer or full, we get everything, right? No matter if there are commonality, we get everything. The commonalities will be attached, but the rest of them will have null values. But with left and right, basically we say I want everything from the left. If you've got other things from the right that there is no match, I don't need them. Or if you say right, you say I want everything on the right. If you don't have other things on the left that doesn't match, it's okay, right? So these are the 4 major types, and we also get to talk about the cross one in a minute. The one that you are going to use the most is the inner join, which is the default one. But there are cases that you might end up wanting to need the other ones, right? So for instance, if we add the inner, we can see that behavior does not change in neither of our methods. But if we did the left, now we can see that our null values for the temperature came back, because we want everything on the customer side, which is the left one, to be here. That's why we say how left. And basically this is the same output as we had when we did applying or we did our own loop. But again, we are doing this in a much faster and less computational expenses, right? If we wanted to have everything from the right, we can say right, and we can see that on this one, we've got some dates that we don't have customer ID and purchase ID, but we've got some dates, right? So that's, when we are enforcing everything on the right has to be in the output. And if we say outer, this is going to actually create the biggest one. We can see we've got 1,007 rows, because we've got some, extra dates that we don't have any customer information from, or some customer information from that we don't have temperature data from, right? The one that makes the most business sense is this one, right? So sometimes based on what makes the most business sense is the one that you need. So that's why you need to understand these types of merging and joining to be able to use the one that is needed for you. All right, so now let's bring our attention to the last one, which is the cross. The cross one is basically a completely different joining and merging the data frame. With the cross one, basically you want to have the combination of all of the possible rows of the data frames to be basically put in front of each other. With cross method, you don't need to have an on property. Basically, you don't have a column to sort of like join or merge your data on, right? We don't have that date in this example that we have. We don't need to specify it because basically we want to have a combination of all of the possible rows. For instance, here I am creating a student df. This isn't a student df. This is because this is a completely different thing. So I'm creating another playground for us. So this is basically for students. So an A, B, C, D, and these are the grades, and I've got 5 tutors, right? These are the quality of the tutors, for instance. Now I want to like have these two data frames joined, but I want to do it in a combination. I want to have a row that has student A with all of the tutor 1, 2, 5, and so on and so forth, right? So I can do this very simply by creating a combination df by using this merge. You can pay attention. I have the how as cross, and I don't put any on because it's not needed for this function, right? So I can see 5 multiply 4 is 20, so I am expecting to have 20 columns, which I do, and I have that combination, right? So for instance, for this combination, I can do a calculation, and this is the difference between the quality of the tutor and the student grade. Now I can use this to basically do a matching based on what tutor should be matched with what students, based on that difference between how good quality the tutor is and how much student needs based on the grades, right? So let's get two other notes. The one that we just talked about is that when we use how as cross, our method is cross, we don't need to add on because there is no column to merge on it. We don't need it. We want to just create a combination. The last note is that even though I said we need to have the same names in our data frames for inner, left, and right, and outer, but we don't have to actually. We can actually go around that by using right on and left on. Right, so let's go ahead and look at what we would have gotten without having to have that, right? So this is the one that we have left, and if I were to change the date, right, from the capital D to date, like basically I'm changing the name of the column here. So let me just show that here for a second before we do the other one. Basically now I have a, I'm just changing the column name, right? And I'm using that to create this. And this generates an error. This is just for us to see when we specify this and it's not the same thing, we get an error, right? But we don't have to basically change the column names. We can basically use the function itself by saying, okay, I want this to happen left on. Basically the column on the left data frame that I want to join happen on is this one, on the right one is this one. So we can use the left on and right one when we just don't want to change the name of the column before joining. Alright, so once we do that, what's going to happen, the join is going to happen, but we're going to have two dates. One is capital, one is the other name, but it's going to do the trick for us. So it's going to work that way. Alright, in this video, we talked about the function Pandas Merge and how it can help us with the data integration. We saw that how this is actually basically an optimization matter, code optimization matter, because we could do the integration with other methods that might sound more intuitive to us, but using Pandas Merge is going to be just better because it pushes your data to be connected together at the CPU level instead of you having a lookup every time you go through each of these loops, whether you use apply or use a loop. We did say that applying is better, but it's not nearly as good as when you use Pandas Merge. All right, until next time.